Heidi-ho, Renaissanceteers, and welcome to Renaissance puzzle number 301, Inscribed Squares. Here's the puzzle. A square is inscribed in a circle. A smaller square sharing one side of the large square and touching the circle is inscribed as shown. What is the ratio of the areas of the two squares? The solution is about to follow, so if you would like to solve the puzzle yourself, now would be the time to stop this video presentation. I'll give you a few seconds. Okay, here comes the solution. Let's start by labeling the dimensions of the two squares. The length of a side of the large square we will call A, and the length of a side of the small square we will call B. The black dot is the center of the large square and also the center of the circle. Let's draw a radius line from the center to the top left corner of the square. And let's draw another radius line from the center to the bottom left corner of the square. This forms a triangle with angles 45, 45, and 90 degrees. Let's label the two radii R, and we already know that the hypotenuse is A. We can use the Pythagorean theorem to find that radius r is equal to a divided by the square root of 2. Let's clear the screen a little bit. Now let's draw another radius line to the bottom right corner of the small square. And let's draw a vertical line from the center of the large square through the center of the small square, dividing it into two halves of width b over 2. This forms a right triangle with hypotenuse r and adjacent sides b over 2 and a over 2 plus b. Again, using the Pythagorean theorem, we can write this equation. Expanding the squared terms yields this simplified equation. Multiply both sides by 4 to get this expression, which simplifies to. Now divide both sides by b squared to get this expression of a over b. Recall that our objective is to find the ratio of the area of the large square to that of the small square, which is a squared over b squared. So if we can find a over b, we need only to square it and our work is done. Let's let x be equal to a over b. So our equation now becomes x squared is equal to 4x plus 5. Rearrange terms to get this standard quadratic equation form. This allows us to use the quadratic formula to solve for x. Plugging the coefficients into the quadratic formula yields this new equation, which simplifies to, which further simplifies to, and which finally evaluates to either 5 or -1. The ratio of two lengths cannot be negative, therefore a over b must be equal to 5. And finally, this brings us to the ratio of the areas of the two squares is equal to a squared over b squared, which is equal to 5 squared or 25. Quod erat demonstrandum.